Hello everyone and welcome to the InSciLab community. I am Rwani Rifi and I'm a scientist and material science researcher from KFS University. As a part of our full Researchers by Researchers initiative, I am here to show you how to calculate crystallite size from XRD data. First, to calculate crystallite size from XRD data, we know to from graph the full width at half maximum, and then we will utilize the value to calculate the crystallite size. We calculate it by using Scherrer equation. Here, that's our equation, that D is equal K multiply in lambda all over beta cosine theta. D here is referred to the crystallite size, K here is a constant, and it equals 0.94 for the cubic system. Lambda here is for the wavelengths that we know it experimentally or from our data. Here that's our data. Here that's our data. From it we will know the wavelengths that used in our experiment. That is the wavelengths for the CU-K alpha. Beta is the full width at half maximum in radian, and theta is the Bragg's angle in degree. Next, we will calculate 2 theta, then divide it by 2 to get theta for the equation to calculate the crystallite size. Now, we will find out the value of the full width at half maximum and the location of theta. From our data here, we are going to plot it. Here, that's our XRD graph. It's between instant t on the y-axis and 2 theta on x-axis. We will select our highest peak, zoom in, zoom in again. Now to find the full width at half maximum to this peak, we are going to analysis, fitting, nonlinear, curve fit, then open dialog. Our category is origin basic function, and our function we will choose Gaussian function. Here as we seen. Now we are going to fit it. Fitting again and fit until converge. Then okay. Yes. Okay. Hey, that's our result. Okay, see here is 2 theta that we need, and the full width at half maximum is equal here. Now we will need to calculate the crystallite size. We can calculate it manually by this equation, or easily we are calculated it by Excel sheet. Here that's our Excel sheet that we are used. I prepared it. We have two constant parameters, K, that's its value, and lambda. We converted it to the nanometer because our crystallite size we will be in nanometer, and the full width at half maximum that we are determined it from our data here, and our 2 theta. Here that's our 2 theta. Now to insert our equation to Excel, we insert it in this form. Here that's our equation in Excel to calculate crystallite size. Here we converted the full width at half maximum in radian and divided 2 theta over 2. Then we need to calculate the average crystallite size to be more accurate and know the all average crystallite size of our material. We will use this equation. Now we are going to repeat all the step in our graph or in our peaks here to calculate our average crystallite size. Okay, that's all. I hope this tutorial was helpful for your research. We would also love to hear your feedback directly. Let us know what you think in comments. Thank you for watching.